This is a key to topic 24, part B, worksheet 1. And on this worksheet, you want to use the rational zero theorem to list all possible rational zeros for the given function. And so there are 5 functions here where you have to list all the possible rational zeros. Now, just as a quick informational type situation, remember that a polynomial function of degree n can have at most n real zeros. And we're talking about real zeros, we're talking about either a rational zero or an irrational zero. So that was one of the lessons that you've learned when we first started talking about polynomial functions. So basically what that means is this. For example, if you look at that first function, the degree here is 5. So that means that this polynomial function will have at most 5 real zeros. It doesn't say it will have 5, it will have at most 5. So either those zeros are rational, irrational, they can be a combination of the two, and then they can also be imaginary zeros as well. But in terms of real zeros, you can have at most 5. Over here, the degree here is 4. You'll have at most 4 real zeros. Doesn't mean that you'll have exactly 4. It means that you'll have at most 4. Okay? The other thing you learned about the rational zero theorem was this. The rational zero theorem describes how the leading coefficient and the constant term. Now remind yourselves about what the leading coefficient is. So the leading coefficient is this. It doesn't mean it's the coefficient of the first term listed, because first of all, remember, it's when discussing the leading coefficient, you're looking at the term that's the highest degree. So it's always a good idea to put your function in descending order. So that way you'll see that the first term, if it's in descending order, the first term will be the leading term. And so the leading coefficient would be the coefficient of that leading term. And so in this case, the coefficient here is 1. Your constant is always the easiest to see because it doesn't have a variable attached with it. And if it's in descending order, it will always be the last term listed. So your constant term is 3. Okay? Over here, your leading coefficient is 1. Your constant term is a negative 35 in this case. All right. So the rational zero theorem describes how the leading coefficient and the constant term of a polynomial with integer coefficients. And so notice that in all these cases, the coefficients are all integers. You don't see any fractions. You don't see any irrational numbers. They're all integers. Can be used to determine the list of all possible rational zeros. And so here's what the rational zero theorem says. If you have a polynomial function of this form, a sub n x to the n, so notice this is the general notation of a polynomial function. And so n's the largest exponent, n minus 1 is the next one, and so on. And so notice your constant term, a sub 0, your constant term is always listed last. And if it has degree greater than or equal to 1, so it must have at least degree 1, and it has integer coefficients, so a sub n minus 1, a sub 2, a sub 1, and your constants, they all are integers. Then and don't forget, a sub 0 cannot be 0. So you must have, in order to use the rational zero theorem, you must have a constant other than 0. Then every rational zero of this function is of this form, p divided by q. And so you may say, what's p divided by q? Well, p, let's go to the second one here. P is an integer factor of the constant term. And q is an integer factor of the leading coefficient. And so you're just going to find combinations of p divided by q. But remember, if you're going to say it's a rational zero, the first one says that p and q can have no common factors other than plus or minus 1. Okay? All right, so let's go ahead and look at the first one. So number 1, I'm going to go ahead and just rewrite number 1 over. So in number 1, we have this function, number 1. All right, so number 1, we have f of x is equal to x to the 5th minus 3x squared minus 2x plus 3. And it's already written descending order. It's a good idea to put in descending order, so that way that first term will be your leading term. And then the last term will be your constant. Okay, so first of all, let's talk about what the leading coefficient is. So my leading coefficient, it's always a good idea to determine that. The leading coefficient is 1. Okay, your constant term in this case is 3. All right, so let's determine what P and Q are. So remember, P are integer factors of your constant term. Q are integer factors of your leading coefficient. So this means this. So P, for the possible values of P, would be the factors of 3. So it'd be plus or minus 1 and plus or minus 3, right? Because plus or minus 1 goes into 3 evenly, plus or minus 3 goes into 3 evenly. All right, so plus or minus. So positive 1 goes into 3 with remainder 0. Negative 1 goes into 3 with remainder 0. Same thing for plus or minus 3. Q are the integer factors of your leading coefficient. So the only factor that goes into 1 is 1. So it'll be plus or minus 1. All right, so then we got to find P divided by Q. So P divided by Q. And so that would be your leading, that would be your possible rational zeros. But keep in mind that you do need to make sure that P divided by Q have no common factors. All right, so let's take the first one. This is the way that most of you are doing this. You said plus or minus 1 divided by plus or minus 1. So notice when I think about this, I always think about the leading the factors of the constant term first, P, and then I always think about, well, what are the factors of the leading coefficient? So that way, when I do P divided by Q, these are your P's, these are your Q's. So plus or minus 1 divided by plus or minus 1. All right, and so plus or minus 1 divided by plus or minus 1 is plus or minus 1, because 1 divided by 1 is 1, right? Then do the next one. Plus or minus 3 divided by plus or minus 1. 3 divided by 1 is 3. So it's just plus or minus 3. And that's it. All right. So the answer to this question right here, where it says answer, so you're going to say the answer is this. So plus or minus 1, plus or minus 3. So what that means is this. Now remember, these are rational numbers. You're only looking at rational numbers, right? These are rational numbers. What that means is that if this function has any rational zeros, it will have to be one of those. So 5 is not a possible rational zero for this, because 5 is not listed. 7 is not going to be a zero for this function, because 7 is not listed. Negative 2 is not going to be a zero of this function, because negative 2 is not listed. Okay? All right. So if this function has any rational zeros, then it will have to be one of these. Okay? It will have to come from one of these. All right. So that's answer number 1. So the answer number 1 is plus or minus 1, plus or minus 3. Okay, let's look at number 2. So number 2, we have this function. We have g of x is equal to x to the 4th minus 7x squared plus 5x minus 35. All right, so let's talk about what the leading coefficient is. So the leading coefficient, so it's a good idea to determine that. Leading coefficient is 1. It's in descending order, right? So the leading coefficient is 1. The constant term is negative 35. And so I'm going to list the p's, the p, which are the factors of the constant term. So p will equal. Now always think about what whole numbers, what integers will go into 35, negative 35. So plus or minus 1, plus or minus 5, because 5 goes into 35, right? In fact, 5 times 7 is 35 in it. So plus or minus 7 is also a factor, also 2 factors that go into negative 35. And then plus or minus 35. All right, so those are the possibilities. Okay, so now we list Q. So Q are the leading, Q are the factors of the leading coefficient, which is 1. So that's only plus or minus 1. And so therefore, we need to find P divided by Q. All right, P divided by Q. So P divided by Q would be this divided by this divided by this divided by this divided by this. Plus and minus 1 divided by plus and minus 1 is still plus and minus 1. Plus and minus 5 divided by plus and minus 5 is plus and minus 5. Plus and minus 7 divided by plus and minus 1 is plus and minus 7. Because 7 divided by 1 is 7, right? And a positive divided by positive is a positive. So you think of all the different combinations. A negative divided by positive is still a negative. So you see the negative. A negative divided by negative is a positive. So you have the positive. And then a positive divided by negative is a negative. Or a negative divided by positive is a negative. So the plus and minus divided by plus and minus is still going to be plus and minus. All right. And then finally, plus and minus 35 divided by plus and minus 1 is plus and minus 35. And you're done. So your answer, so you see your degree is 4, right? Degree is 4. So you can have at most 4 real zeros, some of which may be rational. And if any zeros are rational, it will have to come from one of these that I have listed. Plus and minus 1, plus and minus 5, plus and minus 7, plus and minus 35. So for example, if all of my zeros are rational, then I would have at most, then I would have 4 of them. And some of them could repeat, so you could have different multiplicities, but they would have to be one of these listed. So in other words, 22 is not a zero of this polynomial function because 22 is not listed. Negative 10 is not a zero of this polynomial function because negative 10 is not listed. Is not a rational zero because negative 10 is not listed. Okay? All right, that was number 3. So the answer to number 2 will be, so you see it's very simple, right? Very simple to find those rational zeros. The possible rational zeros, because these are possible rational zeros. So plus and minus 1, plus and minus 5, plus and minus 7, plus and minus 35. All right, so now let's look at number 3. So number 3, we have this function for number 3. We have h of x is 5x cubed minus x squared plus 2. All right, so it's in descending order. The leading coefficient is 5. The leading coefficient is 5. And the constant term is 2. So we're gonna look at P and Q. So P, remember, you got to remember where the P is coming from. P are the factors of the constant term. So P divided by Q. So be careful. It's P divided by Q. So the factors of 2. So the factors of 2 are plus and minus 1, plus and minus 2. Then let's talk about Q. The factors of 5 are plus and minus 1, plus and minus 5. Okay? All right. So now let's find P divided by Q. All right, now notice this time you have, for Q, you have 2 sets of possibilities. All right, so the way I would do this is this. Start with the first one. So plus and minus 1 divided by plus and minus 1, and then we'll say plus and minus 1 divided by plus and minus 5. Okay? So plus and minus 1 divided by plus and minus 1 is plus and minus. 1 divided by 1 is 1. Plus and minus 1 divided by plus and minus 5 is plus and minus. 1 divided by 5 is 1/5. Okay? All right. Now let's do the 2. 2 divided by 1 is 2, right? So plus and minus 2 divided by plus and minus 1 is plus and minus 2. And then plus and minus 2 divided by plus and minus 5 is plus and minus. And then 2 divided by 5. So 2/5. And that's it. So this polynomial function has at most 3 real zeros. And it could be that if there are 3 real zeros, they could all be rational zeros. All right, we don't know that, but it could be. You don't know that yet, but it could be. But if they are, it would have to come from here. All right, so your answer, and it doesn't have to be in numerical order, but you can definitely put it in numerical order. I would just write it the way I see it: plus and minus 1, plus and minus 1/5, plus and minus 2. Plus or minus 2/5. Okay? All right, but over here you must say plus or minus in each case because negative 1 could be a rational zero. Negative 2 could be a rational zero. All right? Okay. So that was number 3. Okay, let's look at number 4. So number 4, we have, oh, let me go ahead and write down the answer. So the answer for number 3 is plus or minus 1, plus or minus 1/5, plus or minus 2, plus or minus 2/5. Okay? All right, number 3. Oh, I'm sorry, number 4. We have um, f of x is equal to 9x to the 4th minus 2x cubed minus x squared minus x minus 21. All right, and then you want to find the possible rational zero. So this polynomial function has at most 4 real zeros. They could be a combination of rational, irrational, uh, and if you don't have all 4 being real, then you would have imaginary zeros. Okay, that's a later topic, but you have at most 4 real zeros. So if they're any rational, let's see what they would be, what they would come from. All right, so the coefficient leading coefficient is 9. It's already in descending order. So remember, the leading coefficient is the coefficient of the leading term, and the leading term is the term with the largest exponent. The constant term is negative 21. Okay. All right. So let's find. Oops. So P then would be the factors of negative 21. So the factors of negative 21 are plus or minus 1, plus or minus 3, because 3 goes into negative 21 7 times, right? And then we can now say plus or minus 7. 3 times 7 is 21. Then we have, and then the last one will be plus or minus 21, right? Okay, and that's about it, correct? Now let's talk about Q. Q, the factors of 9 would be plus or minus 1, plus or minus 3, right? And then plus or minus 9. And that's it. All right, now you have quite a few more here. So let's be a little bit careful. So let's find P divided by Q. All right, now remember one of the things we said was that P divided by Q cannot have any common factors other than plus or minus 1. All right, so let's start. Plus or minus 1 divided by plus or minus 1 is plus or minus 1. Plus or minus 1 divided by plus or minus 3, 1 divided by 3, so 1/3, so plus or minus 1/3. See, it's always helpful to put the p's first. All right, then plus or minus 1 divided by plus or minus 1/9 is plus or minus 1/9. All right, let's do the 3. Plus or minus 3 divided by 1 is 3, right? I don't have it listed, so let's write it. Plus or minus 3 divided by plus or minus 3. Now don't write it just yet, because you know that 3 divided by 3 is 1, and I already have it listed. So you don't list you don't list plus or minus 3 divided by plus or minus 3. So that's that part where the common factors must be 1. Plus or minus 3 divided by 9. Now be careful, don't put that down, because you know that 3 divided by 9 is 1/3. You got to reduce it. It's already listed. Okay? All right, let's do the 7. Plus or minus 7 divided by plus or minus 1 is plus or minus 7. Plus or minus 7 divided by plus or minus 3 is plus or minus 7/3. Plus or minus 7 divided by plus or minus 9 is plus or minus 7/9. Okay, now let's do 21. Plus or minus 21 divided by plus or minus 1 is plus or minus 21. Plus or minus 3 divided by, plus or minus 21 divided by plus or minus 3. So 21 divided by 3 is 7. I already have it listed, right? It's already listed. And then 21 divided by 9. Now be careful. 21 divided by 9 reduced. You got to think about that. 21 divided by 9 reduced. They're both divisible by 3 is 7/3, and it's already listed. So that's it. So those are your possible rational zeros. So plus or minus 1, plus or minus 1/3, plus or minus 1/9, plus or minus 3, plus or minus 7, plus or minus 7/3, plus or minus 7/9, and plus or minus 21. All right? And so that's going to go here for that answer. So you're going to say plus or minus 1, plus or minus 1/3, plus or minus 1/9, plus or minus 3, plus or minus 7, plus or minus 7/3, plus or minus 7/9, and then plus or minus 21. All right, and then finally number 5. So let's look at number 5. So number 5, we have this for number 5. Okay, number 5. So we have g of x is equal to 9x to the 7th minus 9x to the 5th plus 8x squared plus 6. All right, so it's in descending order. So here's my leading term, the one with the largest exponent. So the coefficient is 9. So the leading coefficient is 9. Your constant term is 6. All right, so let's talk about P and Q. So P would be the factors of 6. So plus or minus 1, 1 goes into 6, 2 goes into 6, plus or minus 2, 3 goes into 6, because 2 times 3 is 6, right? And then 1 times 6 is 6. And so plus or minus 6. Okay. Then Q would be the coefficients of 9. So plus or minus 1, plus or minus 3, plus or minus 9. And so P divided by Q, then would be each of these divided by each of these. So 1 divided by 1 is 1, so we get plus or minus 1. 1 divided by 3 is 1/3, so plus or minus 1/3. 1 divided by 9 is 1/9, plus or minus 1/9. All right, so that takes care of that. Then 2. 2 divided by 1 is 2, plus or minus 2. 2 divided by 3 is 3, plus or minus 2/3. And then 2 divided by 9 is 2/9, so plus or minus 2/9. All right, now let's do the 3. 3 divided by 1 is 3. I don't have it listed, plus or minus 3. 3 divided by 3 is 1. I already have it listed, so don't do it any further. Okay? Don't do it any further. You're done with that. All right, and then 3 divided by 9 is 1/3. I already have it listed. Okay, let's do the 6. 6 divided by 1 is 6. I don't have it listed. 6 divided by 3 is 2. All right, I already have it listed. And then 6 divided by 9 reduces 2/3. I already have it listed. So that's it. So those are your possible rational zeros. And so the answer would be plus or minus 1, plus or minus 1/3, plus or minus 1/9, plus or minus 2, plus or minus 2/3, plus or minus 2/9, plus or minus 3, and plus or minus 6. Okay? So that is the key to topic 24, part B, worksheet 1.